In this video, we're going to talk about the oxidation of alcohols. Before we get into the specific oxidation of alcohols, we're going to talk about oxidation and reduction in general. So oxidation, and specifically looking at organic reactions, oxidation is going to be the increase in the number of carbon-oxygen bonds within your molecule, or, and sometimes at the same time, a decrease in the number of carbon-hydrogen bonds in your molecule. Reduction is the opposite. It's going to be a decrease in the number of carbon-oxygen bonds or an increase in the number of carbon-hydrogen bonds. There's a lot of different reagents that can do oxidation and reduction. A lot of times what you will see over the arrow instead of specific reagents for oxidation is just an O in brackets. For reduction, it's a hydrogen in brackets. Some specific examples for oxidation: KMnO4, K2Cr2O7, H2CrO4, as well as others. Notice that each of these do have a relatively large number of oxygens in their formula, so that kind of should indicate oxidation to you. Let's look at a few specifics about oxidation of alcohols. This reaction is one where we need to consider the classification of the alcohol to determine what product will be formed. If we have a primary alcohol, so this is one where we have the OH attached to a carbon that's attached to only one other carbon. What's going to happen is we're going to remove the hydrogen from the alcohol and the hydrogen from the adjacent carbon. And what we are then left with are these atoms. And I notice that the oxygen is missing a bond, as well as the carbon that we removed the hydrogen from. So to fix that, we're going to make a double bond between the carbon and the oxygen. So if I redraw this so it's kind of vertical here, if we think back to the functional groups that we learned earlier, we see that I have a carbon-oxygen double bond, which is that carbonyl. One side is a carbon. The other side is just a hydrogen. So this is an aldehyde. So primary alcohols, when oxidized, become aldehydes. If we have a secondary alcohol, now the carbon with the hydroxyl group is attached to two carbons, which leaves one hydrogen. Again, we're going to remove the hydrogen from the oxygen and hydrogen from the carbon. What we are then left with looks like this. Again, the carbon is missing a bond, the oxygen is missing a bond, and so we're going to make a carbon-oxygen double bond. And when we do that, we see that we have, again, a carbonyl. So we're going to flip it over again. So here is my carbonyl, carbon-oxygen double bond. And I see this time I have carbons attached to both sides, which makes this a ketone. So a secondary alcohol will become a ketone. If we think the same process through a tertiary alcohol, now that OH is attached to a carbon that's attached to three other carbons. For the oxidation, again, I need to remove the hydrogen from the oxygen, and I need a hydrogen on that adjacent carbon to remove, and I don't have it. What I have instead are three carbon atoms. So with a tertiary alcohol, and if we try to do oxidation, there's no reaction. And that is because the carbon that the hydrogen is attached to has no hydrogens that can also be removed. So in summary, primary alcohols become aldehydes. Secondary alcohols become ketones. Tertiary alcohols are no reaction. Here are some specific examples. So first we need to decide primary, secondary, and tertiary. So I have my OH group. I need to look at the carbon it's attached to, and I see it's attached to 2 other carbons. So this is going to be a secondary alcohol, and I know secondary alcohols will become ketones. What I'm going to do with line angle, my thought process is I'm going to keep all of the carbons just as they are. The carbon that has the OH group on it is still going to have a bond to the oxygen. The hydrogen that's on that hydroxyl group, as well as the hydrogen that's on the carbon that it's attached to, are both removed. So the oxygen and that carbon will become a double bond. So there is the ketone that is formed. I have the carbon-oxygen double bond with carbon groups attached to either side of that carbonyl, making it a ketone. Let's look at the second alcohol. So here's the OH. It is attached to this carbon, which is attached to only one other carbon. So now I have a primary alcohol. Primary alcohols become aldehydes. So again, my carbon chain is going to stay the same. It is still attached to the oxygen, but now that carbon-oxygen, what was a single bond, is going to become a double bond. So it's perfectly fine drawing it like this. There is that hydrogen attached to that carbonyl carbon, and on aldehydes, a lot of times it's actually drawn out, so it's also acceptable to show that. If we look at the third example, here's the hydroxyl group attached to this carbon, which is attached to 3 other carbons, making it tertiary. Tertiary alcohols, if I try to oxidize them, is no reaction. So there's no product that is formed in this attempted reaction. Here are a couple more examples, so go ahead and pause the video and see if you can draw the products of these 2 oxidation reactions. Here are your products. The first example is a primary alcohol turning into an aldehyde. The second example is a secondary alcohol turning into a ketone.